Let's go to page 295. This is lesson 5.1. And this lesson is to use mixed segment theorem and coordinate proof. Okay, over here it says a mixed segment of a triangle is a segment that connects the midpoint of two sides of the triangle. Every triangle has three mixed segments. So over here, example would be this one over here, the MP would be the mid segment because it's joined the midpoint. Now, how do you know these are midpoints? Because the markings. See the markings over here? It tells you that these two segments have same length. Therefore, this is the midpoint. Same thing over here. So this marking shows that this is the midpoint because they're equal length. So same thing over here. This are equal length, so this is the midpoint. So this is the mid segment because it joined the midpoint on this side, join the midpoint on this side. This is a mid segment because join the midpoint here, join the midpoint here. This is a mid segment because join the midpoint, join the midpoint. Okay, so theorem 5.1, the mixed segment theorem, it says the segment connecting the midpoints, like DE over here, of the two sides of a triangle is parallel to the third side and half as long as that side. So mixed segment is parallel to the other side, the third side, and is half as long. Okay. So now here's application of how to use the mixed segment theorem to find length. So in the construction, so this is a real life application. So triangles are used for strength in roof trusses. Okay. In the diagram, UV, so that's UV, and VW are the mixed segments. So if this is a mixed segment, means these two are equal, these two are equal. And if this is the mixed segment, that means this is equal because this is the midpoint, and these two are equal because this is the midpoint. So this is a mixed segment, means it connects the midpoints, and these are mixed segments because this is connect the midpoint. Okay? And you want to find the UV, so you want to find the length of that. Since this is the mid segment, this is half the length of the other side, the parallel side. So if this is 90, this is half of that. So 90 times 1/2, you get 45. Okay? So again, this is half of that. So you just use 90 times 1/2, you get UV equal to 45. Now to find RS, okay, you use this. So since this is half of that, or this, the SR, is twice the length of 57, okay, the VW. So RS is 2 times VW, because again, this is half of that, so this is twice as that. Okay, so just 57 times 2, you get 114, so this is 114. So again, this is half of this, or this is twice as that. Okay, so that's an important fact to remember because you're going to be using that to solve many problems. Okay, let's go to page 296. In the kaleidoscope image, AE is congruent to BE. So if these two are congruent, that means this is the midpoint. Okay, the E is the midpoint. And AD is congruent to CD. So if these two are congruent, this is midpoint. So if this is a midpoint, this is a midpoint, then this is a mid segment. Okay? And so if this is a mid segment, then this would be parallel. Okay? Because again, mid segment is parallel to the third side. So since this is a mid segment, so DE is parallel to CB. Again, by the mid segment theorem. Okay, the next thing is when you're doing some proof, sometimes it's harder to kind of use the letter. Sometimes it's a lot easier to use coordinates and use algebra. Okay, so coordinate proof. Okay, so a coordinate proof involves placing geometric figures in a coordinate plane. When you use variable to represent the coordinates of a figure in coordinate proof, the results are true for all figures of that type. So in other words, you use a variable and then whatever you prove will be true, because if a variable is true, then it will be true for all the numbers that you use to substitute into the variable, right? Okay. So over here, so place a figure in a coordinate plane. Okay. Now when you're doing that, you can place any way you want, but you want to choose the easiest way. And so usually you want to place one of the corner on the origin or the 0, 0, because 0, 0 is the easiest number to deal with. So normally you want to do that. You don't have to, but it will make things a lot complicated. If you don't. Okay, so normally you want to place one corner, one of the vertex on a 0, 0. Okay, and you make your algebra, make your math a lot easier. Okay, so it says place each figure in a coordinate plane in a way that is convenient for finding side length. Assign coordinates to each vertex. Okay, so for a rectangle, so you have rectangle, you want to place over here. Okay, now, so you place a rectangle with one of the vertex on a 0, 0, right? And then the length is h, and the height is k. So if this is h, so to figure out the coordinate, you just kind of trace along the path. Okay. So remember, when you go this way, it's x, right? So when you go to the right, you add. When you go to the left, it's negative direction, so you subtract. Same thing. If you go up, you have to add y, and when you go down, you have to subtract in the y direction. Okay. So focus on the x. So x is 0, right? So 0. So when you go to the right, you add. So 0 plus h. That's how you get h. Okay. And since you're going sideways, the y does not change. That's why y stay the same. Okay. Now when you go up, okay, again, you now go up and down is y, right? So you look at the y coordinates. Okay. So for the y coordinate, it's 0, and so you go up, you plus, right? So 0 plus k. That's how you end up with a k. Okay. And once you find this, right? To find this again, you do the same thing. So from here, see the x is 0, right? So x is 0, and you go this way, you add. So 0 plus h, that's how we get h. Now to find the y coordinate, right? The y coordinate is k. When you go sideways, the y does not change, and that's why it stays the same. So you can get this from here going sideways, or if you can get it from here too. So from here, right? See the x coordinate is h, right? So when you go up and down, the x stay the same. So h. When you go up, it still stay h. Okay. Now the y coordinate is 0, so when you go up, you have to add, right? See the k? That's how much you have to go. So 0 plus k, that's how you go. That's how you end up with a k. So that's how you find the coordinates, by follow along the path, okay? Whether to add or subtract. Okay, you go up, you add in the y. You go down, you subtract in the y. Okay. Now for a scaling triangle, okay, you put one of the vertex in the origin, the 0, 0. And you call this length d, okay? And therefore you go 0 plus d, that's how you end up with d, right? And the y coordinate is 0. When you go sideways, the y stay the same. That's why you still have the 0, okay? Now this is a random point out there, so it doesn't, relate to anything. So you just assign a variable for the x and another variable for the y coordinates, okay? So that's how you set up your coordinate. You set up your figure in the coordinate plane and get ready for the proof. Okay, so now let's go and do this one here. Okay, so example 4, it says place an isosceles right triangle. So isosceles right triangle, again, it's a right triangle, right? So you can rotate any way you want. Okay, but to make things easier, since this is already a right angle, so for the right triangle, you want to put a right angle on the corner over here. Again, it will make things a lot easier. So as you place your figure on the coordinate plane, you have to think. Okay, you have to use your thinking to decide where to place it and how you rotate it. Okay, to make things easier. Okay, because if you rotate it the other way, if you make it look like this, it makes things a little bit harder. Okay, so you have to do a little bit of thinking to figure out how you're going to place the figure in the coordinate plane. So again, it's a right triangle. So you put the right angle in the corner over here. Okay, and it's isosceles. Isosceles means the legs are the same. So you can assign any length. We're gonna call it k. Okay, because isosceles means two legs are equal, right? So you call the length k and length k, right? Because they're equal. So if they're equal, use the same letter. Okay? And so because this is length k, so when you are going sideways, again, sideways is x, right? So 0, plus k, that's how you end up with a k. For the y coordinates, when you go sideways, the y stay the same. That's why 0 stays 0. Okay? So this corner, that's how you get the coordinate for that. Now to get the coordinate for this vertex, right, you go up, right? So when you go up, the x coordinate, when you go up and down, the x stay the same. So 0, when you go up, it stays 0. Okay? Now for the y coordinate 0, when you go up, you have to add amount, right? So 0, you go up this amount, that's how much then you add, right? So 0 plus k, you end up with a k. So that's how you get these coordinates. Okay? So once you set things up, now you can try to answer the question. It says find the length of the hypotenuse and the coordinate of the midpoint. Okay? So let's go and do that. Okay? So this is page 297, example 4. So when you try to do the problem, try to make the picture big enough so that you have room to write things in there. Okay? Okay, so this is the O stand for origin. Okay, 0, 0. And this is point P at 0, K. And so this is the length of K, and this is length of K. Okay, again, you want to label things so they help you to, visualize and make things a bit easier. Okay? Okay, so find the length of hypotenuse. Okay? Okay, well, to find the length of hypotenuse, right, you can use the distance formula, but sometimes people kind of have a hard time memorizing the distance formula. Okay? And it's sometimes it seems more complicated. So a lot of times they use a Pythagorean theorem, so you can do it either way. So Pythagorean theorem is a squared plus b squared equal to c squared. Okay? So a and b are the legs. So a would be k. Okay? Right? You already know the length already. Okay? If you don't, you just go and use the end minus beginning. Okay? So k minus 0 give you k, right? Okay, and b, again, is also k. Okay? And c is your pq. Okay? So so again, that's your ABC, right? C is always your hypotenuse. Okay, from here you solve. So you got k squared plus k squared equal to pq squared. So you got 2k squared equal to pq squared. And you take the square root. So from here you take the square root on both sides. Okay? So take the square root on both sides. So you have pq equal to, when you take the square root, right, the k squared can come out, so become k square root of 2. This one don't have enough to take out and just leave it like that. So that's your answer for hypotenuse. Okay? Now the next thing is you have to find the midpoint. Okay? Midpoint is over here. So you have to know the midpoint formula. Midpoint is the average of the two numbers. Okay? So the midpoint for the x, okay? So for the x coordinate, you have to average the two. To average, you divide by 2. So you're going to get 0 plus k divided by 2. So that's 0 plus k divided by 2. That's the average for the x. Now for the y, you're going to get k. So you got k plus 0. So keep track of your x and the y. Okay, that's how you find the midpoint. Again, midpoint is average of the 2 points. But make sure you don't mix the x and the y. You keep the x with the x, y with the y. So 0 plus k, right, over 2, k plus 0 over 2. So your midpoint would be k over 2, k over 2. Okay, and that's your answer for the midpoint. Okay. Okay, let's go to the next one. Let's go to example 5. Okay, write a coordinate proof of the mixed segment theorem for one mixed segment. Okay, so over here they kind of give you the picture already. They kind of nice. They kind of do they help you to place it already. Okay, so again, this is the origin, so it's 0, 0. And let's call this point C and call this point B. Okay, again, you can assign any length. Okay, notice they have 2, they use 2, so they call this length 2p. Okay, so therefore this will be 2p comma 0. And the reason you use 2p instead of single p because because they're going to divide. So once you divide by 2, it will come out with a nice letter instead of just instead of fraction. That's the reason for that. Again, this is a random point. You can assign anything you want. So they're going to call this point 2q, 2r. Okay. Okay. So write according to proof. So let's say DE is a mid-segment. So that means this is congruent to this, and this is congruent to that. So you want to prove that this is parallel to that, and that this is half of that. Okay? Okay, so first we find the coordinate of the D. Okay? So D is a midpoint of these two. So D would be, remember how to find midpoint? You average the two, right? So it would be 0 plus 2q over 2, right? 2q plus 0 plus 2q, and then you're going to get 0 plus 2r over 2, right? That's the midpoint, right? Midpoint, you average the two. So the coordinate of D would be qr, okay? Okay, so this is qr. Now you see why they use a 2, because you have to divide, right? Do the same thing for E. So for point E, you have to use 2q plus 2p divided by 2, right? Again, to find midpoint, you have to add, divide by 2. For the Y, you're going to get 2r plus 0 over 2, right? Again, you add, divide by 2, right? That's how you find the midpoint, the average. So the E, so when you add, and notice you can divide it by 2, so it becomes q plus p, right? Dividing by 2. This one divided by 2, you get r, okay? So this point is q plus p comma r, okay? So first, you want to prove they are parallel. Okay, to parallel, if you notice the slope equal to 0, okay? So if you notice the slope of DE, right? The slope of DE, remember how to find slope, is y2 minus y1. So y2 minus y1 over x2 minus x1, okay? And so the slope of DE equal to 0, okay? And if you look at the OC, the slope of OC, okay, you're going to get 0 minus 0, right? 0 minus 0, that's y2 minus y1, okay, over x2 minus x1. So you got to know your slope formula. So you're going to get slope of OC equal to 0, okay? Now, since both are equal to 0, so you got slope of DE is equal to slope of OC. So 3 dots means therefore DE is parallel to OC. Okay? So again, the 3 dots means therefore. Okay, so you prove that first one. Okay, now next you have to find the length. Okay? Okay, so the length of OC equal to, now since this is a horizontal, so you can just use the end minus beginning. So equal to 2p minus 0 equal to 2p. Okay? Now the length of DE, again, because the slope equal to 0, so you don't have to use the Pythagorean theorem or the distance formula because it's horizontal distance. You just use the end minus beginning. Okay? So this will equal to q plus p, right? That's q plus p over here. So use the end point minus the beginning point, because they are the same. See the y are the same. So you don't have to use the distance formula. You can, but you just make things complicated. Okay? And so DE equal to P. So you can see that DE equal to 1/2 OC. Right? See that? And so that's how you do the proof. Okay?